Okay, so we have finished our work on planet Venus, and we are going to move on to our next location, which is going to be... No, not Detroit. We're going to go to Mars next, everybody.
It's not the asteroid belt?
Utah.
Nope, not yet. We'll get to the asteroid belt.
Isn't that in between Earth and Mars?
Nope, that's between Mars and Jupiter.
And also Detroit and Cleveland.
And Detroit and Cleveland. Very good. Mars is the dusty planet. Dusty is also the name of my first pet, for trivia's sake. Yellow Lab. Probably not. A little bit about the history of Mars here. Go ahead and write this slide down, please, before he beats you up. On account of Mars's red color, it was named after the Roman or Greek god of wisdom. Yeah, you can skip the third one. But it still would be a good idea to keep in mind not to mess with them. So in terms of some more information about good old planet Mars, you might know that in the past people thought that aliens and Martians lived there. And the reason they thought that is they were able to see these little channels that were going across the surface. And people thought that they could see through their telescopes that these were irrigation channels that were dug by aliens in order to help sustain their dying, drying up world. Pictures like this came out in popular science magazines, and there are all sorts of different ideas about what these little aliens on Mars look like and what their lifestyles were like. As we get closer and closer to the surface of Mars and the USS Hathaway, though, we notice that these channels are all dried up. There's nothing there. Doesn't mean there never was anything there, but there's nothing there right now. So this is what we see as we approach the surface of Mars, and when we finally land, this is the kind of view that we get. And this is pretty accurate compared with what you see in movies generally. You got the red surface, and you've got kind of the orangish atmosphere, and that's the sort of thing you would find. It looks a little bit different in the atmosphere, depending on if it's sunrise or sunset, and we'll get into those colors shortly. But it looks kind of like a desert, basically. But this is not sand, as you'll find out soon enough. In terms of this slide, you can skip it. Good for you. Sorry. But a couple interesting things I'm trying to be more selective about Mars's information because there's a lot of stuff that's going to be in this slideshow because it is a very well-explored planet. So the northern hemisphere, it is rocky, it is cratered. It's mostly shaped from erosion by dust storms. So the northern hemisphere tends to be a lot smoother than the southern hemisphere, which is mostly shaped by the old lava flows. So these are going to be pieces on that planet that are not very smoothed over. Because what these dust storms do in the north is they erode and they carve away everything until you've got a nice smooth surface. And you'll see just how extensive these dust storms can be in just a little while here. Surface features, you can skip this, but we've got some craters. And this is an interesting crater right here. 16 meters in diameter, give you a bit of size right there. So it's about 45 feet or so. And from that impact, we noticed there was some bluish, purplish material right underneath the surface of Mars. So that was in the news last year. Another close-up view of it right there. And that's just one location. Something that you'll notice and you would not be able to avoid if you looked at the planet from any distance are some of these deep valleys. We're going to talk about this one specifically in a little while here. It also has large volcanoes, the largest of which is called Olympus Mons. You can go ahead and write this one down. Yep. So this is much larger than any of the volcanoes that we have on Earth here. And it's got much different characteristics too. The volcanoes that we have on Earth are generally very cone-shaped. This one, it's not a very high change in elevation. It really grades downward at a very shallow angle. And that's something we don't usually see on Earth here. So it's called a shield volcano. That's what that first bullet point means. And basically the characteristics of that mean that when this volcano was erupting, instead of going and going everywhere, it was more like a blah, blah, and it just kind of falls down the edges. So nothing really action-packed if you went far enough back in time and saw this happening. But yeah, it is a volcano nonetheless. That's what it looks like if you back up a ways and see how it looks from space. And this is how big it is compared with the biggest mountain on Venus and the biggest mountain on Earth, Mount Everest. So, pretty massive there. And to see how much area this would take up, because it's a shield volcano, it spreads out a long ways. If you put this in the United States, it takes up a pretty large portion of it. Alright, this is the Valle Marineris. This is an enormous canyon, and it's so big it makes the Grand Canyon look like chicken feed. 2,500 miles long, 125 miles wide, so it's about a third of Wisconsin wide. That's how wide this thing is. From this slide, right down Valle Marineris, largest canyon in the solar system, And I think that's good. If we ever colonize Mars, this will be a popular tourist attraction. They will charge many Martian dollars to get a view of that. Did you guys hear? I heard on the radio today, this is the first time I heard this, that NASA plans to send people, and this is not a dad joke, NASA actually plans to send people to the moon by 2024. This was the first I've heard of that. So, yeah, that's going to be awesome. I'm glad they make it a priority. Among many other things, yes. So when you look at Mars, whether it's through online pictures or in movies, typically this is the view you're going to see, and this gigantic scar running across its middle, that's the Valley Marineris that you just took notes on. So it runs along a huge portion of this planet. From this slide, go ahead and write down Tharsis and Hellas. Write down Tharsis and Hellas. And this is an elevation map. So write down that Tharsis is the highest elevation, Hellas is the lowest. And on this map, again, yeah, Tharsis, highest elevation, Hellas is the lowest elevation. So you can kind of tell from this map, remember when I said how the northern hemisphere is mostly shaped from erosion by dust storms, and that's why we have this enormous borealis basin up here. Because all of these features, which used to be present in the past, have all been eroded away, and it's big and smooth up there. It makes it real easy to land a spacecraft up there. But down here we've got a lot more geography, a lot more things going on, craters, rough terrain, and that's mostly shaped by old lava flows. In terms of time, this is kind of nice. Mars spins on its axis in 25 hours. You can write this slide down. So unlike Venus, which has an enormously long day, and Mercury, which also has a long one, but not as long as Venus, Mars actually spins on its axis in 25 hours. So it's pretty similar to Earth in terms of how long a day is. So that's nice if we ever did find our way there and wanted to stay for a while. As you would probably guess, its year is quite a ways longer than the Earth because it's further from the Sun than the Earth. So it's going to take longer to cover that distance. Fourth planet from the Sun, 1.52 astronomical units. So again, it's like if Earth is, 1 astronomical unit, it's not twice as far away from the Sun as the Earth. It's between the Earth and twice as far. Orbital speed 15 miles per second, so Mars, even though it's much slower than the other planets, is still moving very quickly in its orbit. 53% the size of the Earth. You can skip this. You could fit 6 Marses inside of Earth. You can skip that too. But this is a good, accurate size comparison here. Average density on Mars, 3.93 grams per centimeter cubed. So it's not as dense as the Earth, not as dense as Mercury or Venus, but it's still much more dense than something like water. Now, in terms of seasons, Mars also has another characteristic that is similar to the Earth. You can write this slide down. It has its own version of 4 seasons. Yeah. So if a year on Mars is twice as long as a year on Earth, you would expect the seasons to be twice as long, and that's exactly what we see. They don't have snow during winter or anything, but as far as temperature changes, they have their own seasons. Any guesses on how warm it gets on Mars during the summertime? Maybe 400, 127. The moon was, I think, in the 300s, maybe? Maybe 217. Here's how hot it gets on Mars during the day in the summertime.
Oh, what?
Well, that's not bad, is it? Now, of course, this isn't a typical, this is like if you're in the warmest spot on Mars, like along the equator, in the summertime, during the warmest time of the year. So this is as hot as it gets. It's not going to get much warmer than that. As you can imagine, as it turns into nighttime and other times of the year, it gets much colder. The climate in the summertime would not be a big obstacle whenever we end up landing on and hanging out on Mars for a while. The biggest, write this down. I'm sorry, if you didn't write it down, you can write that down. The biggest obstacle would be what happens in the winter, because during the winter, it gets down to negative 130. So yeah, in this picture here, Mars is located right there. So you can see, compared with the surrounding stars, it is rather large, but it's not by any means the largest, brightest thing in the sky. It's the third brightest star-looking thing behind Venus and behind Jupiter, which we'll get to later. So in terms of what it looks like with a telescope, it sort of looks like small orange. And if you have the right filters, you can actually see the white things that appear at the poles. As far as this slide goes, just write down, with a telescope, resembles a small orange. So it's kind of interesting what we'd see if we land on Mars and we observe the sun rising and the sun setting and what it looks like during the day. In terms of this, write down the question and then write down, you probably can skip night, but write down the other 3 bullet points. Yeah, you can skip night. Because it's, of course, it's going to look black at nighttime. But the others, make sure you get those down. Pay special attention to the 3rd bullet point, too, because that's the most interesting one. Just a few other things to kind of take a look at as we explore Mars here. So yeah, during the day, you've got this orangish red sky that we're used to from the movies and everything. Occasionally, you'll get a purplish sky, and that has to do with what's going on in the atmosphere, how much dust is there as a result of all those dust storms. And at sunset, it's interesting because on Earth, we've got the blue sky, and it turns red towards the setting sun. But on Mars, it would be the exact opposite. The sky would be a rosish color, but it gets bluer near the setting sun. A lot of interesting things happen with optics when you're looking through a big dust cloud, which is Mars's atmosphere. Okay. Okay. So in terms of gravity, 38% of Earth's gravity, you'll feel a little bit lighter on Mars, definitely would be noticeable. No. Roughly twice your jump height. A little bit more, maybe. But if you're wearing a spacesuit, you're not going to jump that high anyway. It is inactive geologically. You can skip this slide too. But when we look at places like Olympus Mons, we can see clear evidence of past geological activity. We just don't see any occurring right now. In terms of its composition, you'll find this on your handout. What I'd like you to take a look at and make a little star next to is this final bullet point. Mars is red because of iron oxide. That's why it looks all reddish. So what's another name for iron oxide? Anybody know?
Rust.
Yeah. So if you've ever gotten those fine grains of rust off the bottom of your car or something, that's the sort of thing that makes up the entirety of Mars's surface. and that would make a lot of difficulties come from that. And I don't want to talk too much about that right now because I'm going to have you guys think about that yourselves in the next couple days. In terms of its magnetic field, this is on the other side of your handout. There's nothing you need to really point out about this, but one of the big difficulties with kind of hanging out on Mars is the fact that it doesn't have a consistent magnetic field. It's located in a couple small isolated areas, but otherwise the entirety of Mars's surface is subject to the radiation and the solar wind coming off of our sun. And that would be a big obstacle. We'd have to find ways to protect ourselves from all that radiation. Its atmosphere isn't going to protect us because it's very thin and it has no magnetic field. So that would make it very, very difficult to hang out there for too long. And that's the result of Mars's magnetic field. The planet's just getting pelted by all that radiation. Go ahead and write this one down. So in the same way that a lot of energy is released when you have evaporation, and you can feel that energy yourself, you know, when you take a shower in the morning and then you turn that shower off, you feel a little chilly for a while. Same thing, same reason that you feel chilly when you get out of the pool, because all of that water is evaporating. It's taking that energy from you, and you feel colder as a result of that. More energy is released when dry ice goes from a straight solid to a straight gas. And a result of that energy are these strong winds. And that occur in the springtime on Mars near the poles. Now again, this is dry ice. This is not the stuff you could melt and then drink. As far as that kind of stuff goes, you can just write down this part of the slide. That good kind of ice is located along the equator just below the surface. So that's cool anyway. That would help us out if we wanted to stay there. No. That would be a big difficulty. If it had a decent magnetic field and a little bit stronger of an atmosphere, you'd be getting pretty close to something that you could actually stay at and not die right away. So, of course, you can't grow anything there. It doesn't exactly have fertile soil, so it'd be hard to make your own food. But if you had a constant delivery service, that'd be easier. So yeah, the water ice that you could melt into something you could drink is present around the equator just below the surface. This is one of the reasons we know that. Whenever we see craters form in that area as a result of meteoroids hitting, you can see that there's white stuff there, and eventually that white stuff goes away. It goes away because it sublimates, because it's exposed to the sunlight, but it is there. Also, of course, when we look at Mars, people think they see all sorts of different things like skulls. This is one of the famous skulls that people think show extraterrestrial life on Mars. There's a face on Mars. One of the things you got to realize when you see pictures like this is that these pictures, in order to see them this way, it would not look like this if you were standing above this location. You have to put on the right filters and have the right shadows to get this sort of an effect. And of course, the most famous Martian. You guys know Marvin the Martian? Oh, good. So there's also a Bigfoot sighting. You can skip this, but a couple things would happen if you landed on Mars without a spacesuit. You would not die right away, but if I had to pick a planet to land on, and without a spacesuit, it would not be Mars, for the simple fact that you would last longer and suffer for a longer period of time. You'd have circulation issues, ruptured lungs, tissue damage, blindness, because it doesn't have a strong atmosphere. But if you had a spacesuit on, you'd be just fine. So that's one of the reasons that we would pick Mars to go to, as opposed to a place like Venus, where you'd die before you reach the ground. Oh, this is another thing. Write down the bottom bullet point. This will be the last thing you need to write down. So this is a slide that points to Mars being younger than billions of years. Just the bottom. And again, when it says long, it's talking billions of years. They couldn't have been around for billions of years because they would not still be here. Just a couple other things to wrap this up then. No need to write any of this down. Most studied planet of the solar system aside from Earth comes in first place for nothing. Poor Mars. But it does come in, yeah, give it some applause. Second place for the second most explored, second most habitable planet out there.
It comes in first place for least awards.
Comes in first place for what?
For least person.
Yeah, that's right.